welcome to your third lesson. In this third lesson, what we're going to be doing is we're going to be solving multiple step equations. So chapter 2, lesson 3, solving multiple step equations. Our objective is to solve equations involving more than one operation. We're also going to solve equations that involve consecutive integers. And these are our standards. Let's go ahead, copy our vocab, start today's lesson, and let's see what we do. Alright, so for our vocab, we have 3 vocab words. We have multi-step equation, which is just equations with more than one operation. Operations are addition, subtraction, multiplication, and division. So multi-step equation might have a couple different operations happening. And our job is to undo those by doing inverse operations, which is what we talked about in the previous lesson. But now instead of doing one inverse operation, we might be doing multiple inverse operations to get to our solution. Consecutive integers are integers that are in counting order. So consecutive integers would be like 1, 2, 3, 4, or consecutive integers could be like 4, 5, 6, 7, 8, 9, 10. So as long as they're in counting order, that's consecutive. Number theory is the study of numbers and the relationship between them. So when we're studying numbers and how they kind of work together, that is number theory. Number theory is the study of the relationship between numbers. Let's start our first example. In example 1, what we're going to be doing is we're solving 2 times q plus 11 equals 3. So the way I read it is what operations are happening. We have 2 multiplied by q, we're adding 11, and that total is equal to 3. In algebra, our job is to figure out what our variable equals. So what we're going to do is we're going to work backwards as well as forward to get to that solution. So what we always want to say is one of the things I say that our goal is to find q. So what we want to do is we want to look at the variable side, just the side with the variable. So draw a line through the equal sign. Look at the variable side and ask ourselves, what is happening to our variable? So I want to know what's happening to the letter Q here. There's actually 2 things happening. One of the things that's happening is we have 2 timesing Q, and the other thing is happening, we have Q and we're adding 11. So we have 2 things happening to the letter Q. The 2 here is multiplying by Q, and 11 is adding to Q. So these right here are the 2 things that we're going to have to get rid of. We're going to have to get rid of 2 times, and we're going to have to get rid of adding 11. And if we get rid of those 2 things, we will be able to get to our solution. I suggest that instead of getting rid of multiplication first, you always get rid of addition or subtraction. So let's go ahead and write that down here. These are just suggestions. They're not actually things that you have to follow. You could get rid of multiplication first, but instead, if you do that, you're going to work with a bunch of fractions, and a lot of you don't like fractions, so I suggest trying to get rid of addition or subtraction, then multiplication and division. So I'm going to say that the steps that we're going to do right now is the first step, we're going to write get rid of adding or subtracting. The second step, we're going to say get rid of multiply or divide. So the 2 things we're going to do is we're going to get rid of adding and subtracting and get rid of multiplying and dividing to start these problems. So I'm going to go ahead and rewrite this problem. I have 2q plus 11 equals 3. My goal is to figure out q, so that means get q by itself. So I'm going to draw a line through my equal sign, and I'm going to say I want q by itself. I need to get rid of whatever's happening to q. So what's happening to our variable? Well, we have 2 is multiplying by q, and q is adding 11. Now, I suggest getting rid of adding or subtracting first. So I'm going to get rid of this part first, the adding 11. Well, to get rid of adding 11, we do the inverse of adding, or the opposite of adding. The opposite of adding is subtracting. So we're going to subtract 11 on one side, and we're going to subtract 11 on the other side. 11 minus 11 cancels out. We have 3 minus 11. Hopefully you know this answer. If you don't, it's negative 8 equals 2 q's. Now notice that the 11's now gone. I don't have Q adding 11 anymore. So what we did was by doing inverse operations, we still kept the equations equal to each other, but we were able to eliminate by doing what we do to one side to what we do to the other, and by doing inverse operations, which is what we learned in the previous lesson. So this, we no longer have to get rid of. That's gone. We already did get rid of it. But look, do we still have 2 times Q? 2 Q's? That does mean 2 times Q. So to get rid of multiplication, again, we're doing the inverse of multiplication, or the opposite. The opposite of multiplying by 2 is dividing by 2. So if we divide by 2 on one side, we divide by 2 on the other. Q equals a negative 8 divided by 2. That's a negative 4. So my answer to this problem should be negative 4. Now what I'm going to do is I'm going to check it by kind of working it out. So I'm going to kind of write it over here. I have 2. I'm going to multiply by negative 4. I'm going to add 11 and see if it equals 3. If it does equal 3, we're good to go. If it doesn't, we need to go back and change our answer because the answer we got is wrong. 2 times negative 4, that's negative 8. So I have negative 8 plus 11, and my job is to see if it equals 3. Well, a negative 8 plus 11, that's 3. And 3 does equal 3, so negative 4 is correct. So this is my solution, and you don't need me to tell you if you got it correct or not. All you gotta do is put your number in the spot of your variable and see if it makes a true statement. If it does, you know you got the correct answer. If it doesn't, you need to go back and see, did you do something wrong? Did you do something right? And where did the mistake happen? And if you make mistakes and you need help, by all means, ask questions, come up to me, I'll help you out, and we'll get to that answer. In our second example, what we're going to be doing is we're going to be solving k plus 9 divided by 12 equals negative 2. So over here, we're going to write our goal. Well, our goal is to find the value of what variable? Well, in this case, our variable is k. So look at the letter k, and then all we got to do is say, what's happening to the letter k? Well, if you look at k, we have adding 9. So we're going to have k adding 9. And we also see this. This means division. That's a division bar. So we have k is being divided by 12. Alright, so we have k is adding 9 and k is dividing by 12. But there's something special happening. If you guys remember, whenever we were working on order of operations, we said when working with a fraction, you always have to solve everything on top first, and then solve everything on bottom second. Since you usually solve that first, what we could do is we could say this entire thing here is actually being divided by 12. Since this entire thing is being divided by 12, and that's happening to everything first, we need to get rid of that first. Whatever's happening first that is going to both numbers, we have to get rid of it. So since we have this entire thing being divided by 12, we're going to get rid of division of 12 as our first operation. I'm going to make these stats a little bit bigger so it doesn't look like a minus sign to me. So we're going to get rid of division of 12. Well, the inverse of dividing by 12 is actually multiplying by 12. So we're going to go ahead and write this problem again. I have k plus 9 divided by 12. This is what we're solving, and we know it equals negative 2. Okay, since this thing is kind of like it's in parentheses, to get rid of division of 12, we're going to multiply by 12. And if we multiply by 12 on one side, you got to multiply by 12 on the other side. Well, multiplying by 12 and dividing by 12 is like 12 divided by 12, which equals 1. So we can just say we cancel those units out. So those are gone. Well, if those are gone, the only thing left is k plus 9. Let's go ahead and drop that down. Equals a negative 2 times 12 is a negative 24. So right now, we're saying that k, a number plus 9, is equal to negative 24. Now we have to get rid of that. But notice, we got rid of divided by 12, so I'm going to cancel that out. If I get rid of those two things that's happening to the variable, I should have my solution. Normally we get rid of adding or subtracting, then multiplying and dividing. In this case, we had to get rid of division first because it was happening to the entire thing. So we need to get k by itself. So we need to get rid of adding 9. To get rid of adding 9, we're actually going to subtract 9. And if you do it to one side, you got to do it to the other side. 9 minus 9 cancels out. So we have k equals a negative 24 minus 9 more. Minus 9 more. That's a negative 33. So negative 33 should be my answer. I'm going to go ahead and check to see if this is true. So we have negative 33 plus 9 divided by 12 should equal a negative 2 for our final answer. And if it does, we get it right. So I'm checking my math. I plugged in negative 33 for the letter K. I'll use a calculator to help me out. Negative 33 plus 9. This is a negative 24 divided by 12 equals negative 2. Well, a negative 24 divided by 12, that's 24 divided by 12 is 2. And a negative divided by a positive is a negative. So does negative 2 equal negative 2? If it does, we know we got our answer correct. So this is the correct answer. And I checked this answer by plugging it into the problem and seeing if it gave me the right solution. If it does give you the right solution, you got the right answer. Doesn't, we need to go back. All right, in example 3, we're going to be solving 6 times v plus 7 equals negative 5. So in this case, we're finding, for our goal, we're figuring out v. That's our goal. We need to find what v is. What's happening to the letter v? Well, we have times 6, because that's 6 times v, and we have plus 7. In this case, since the entire thing doesn't have something that's happening to everything first, we can choose which one of those we want to get rid of. If you don't want to work with fractions, though, I highly suggest you get rid of adding or subtracting first, then multiplying or dividing. Let's go ahead. We'll start by drawing a line through our equal sign. And let's get rid of adding 7. Well, the opposite of adding 7 is subtracting 7. If you subtract 7 from one side, subtract it from the other. 7 minus 7 cancels out. And now we have 6 v's equals a negative 5 minus 7 more. Well, minus 7 more is negative 12. So we have 6 v's equals negative 12. Or 6 times something equals negative 12. Our job is still to figure out v. So notice that the plus 7 is gone. So if we want, we can cross that out and say, well, that's the only thing we got to get rid of now. We still have 6 times v. To get rid of multiplication, we do division. And we get v equals a negative divided by positive is a negative. 12 divided by 6, 2. V equals negative 2. As always, we should check our solution. I'm going to use a different color. So I'm going to say, if I said 6 times negative 2 plus 7, do I equal negative 5? If I do, I got my answer right. If I don't, I need to go back. 6 times negative 2. That's negative 12. Negative 12 plus 7. Negative 12 plus 7. That's negative 5. And does negative 5 equal negative 5? Yes, that's true. So our answer is correct. We know that a negative 5 does equal negative 5. Since that's the case, this is the right answer to our problem. All right. In example 4, we're going to be solving an even more multi-step problem in this case. We have 4 times j minus negative 4 divided by negative 6 equals negative 12. And again, since we have a fraction, we want to get rid of we want to treat it like the top is in a giant set of parentheses, which means that this entire thing on top is being divided by negative 6. Since that's the case, we want to get rid of divided by negative 6 first. Then we want to talk about what other things are happening. Well, if we look at this, we have a 4 next to j, so we're going to get rid of timesing 4. We have minus negatives. Now, before you actually get rid of that, you should know what a minus negative means in mathematics. When you have minus negative, that's the same as 2 negatives equal a positive. So in this case, we're actually going to get rid of a plus 4. So we're going to solve this problem by getting rid of these three things happening to it. So in this multiple step problem, we have three different things happening, and we're going to work backwards by doing inverse operations to get our solution. The first thing we're going to get rid of is divided by 6 because the entire thing is being divided by 6. So to get rid of divided by 6, we're going to multiply it by negative 6. Multiply it by negative 6, sorry, this is divided by negative 6. It's very important that you keep your sign with it. A negative divided by a negative cancels out, and 6 divided by 6 cancels out as well. So now we have 4j plus 4 equals a negative 12 times a negative 6. A negative times a negative, that's a positive. 12 times 6, that's 72. Okay, so now this is what we're working with. We've got rid of divided by negative 6, so we can cancel that out. Now we have to get rid of these two things. And again, which one do you think that we should get rid of first? Hopefully you're saying that we should get rid of adding 4 before we get rid of times 4. Because normally we want to get rid of adding or subtracting, then multiplying or dividing. So in this problem, we're going to get rid of adding 4 by subtracting 4. And if you do it to one side, do it to the other. 4 minus 4 cancels out. So we're still left with 4j's, because they haven't just gone away, equals 72 minus 4, that's 68. So we have 4 times j equals 68. And again, the plus 4 is gone. So the only thing we have to get rid of is times 4. So to get rid of multiplying by 4, we're going to divide by 4. Do it to one side, do it to the other. This cancels out, and we get j equals, okay, well, I know 6 divided by 4, I can do that once, and then I have 28. And 28 divided by 4, that's 7. So this should be 17. J should equal 17. Let me double check that answer. Four times 17, that's 68, plus 4, that equals 72. 72 divided by negative 6, that equals negative 12. So J equals 17 is correct. I did the math in my head. I said 6 divided by 4, I got 1, but then I had 28 left. So that 1 is my tens. And then 28, 4 times 7 is 28, so that's how I got 17, by the way, if you were wondering how I got that number. So that's our answer, and I just checked in my calculator, and I did get negative 12 as it wanted me to get negative 12 when I put 17 into the problem. We're going to do one more problem that has multiple step equations, and then we're going to talk about consecutive integers, and that'll pretty much finish up this lesson, which is a pretty quick lesson for you guys. Alright, for our last example on our multiple step equations, we're going to solve this problem here. So notice that now we have a number outside parentheses. So this 2 is happening to all of this. Then we have minus 7 equals 10. So in this case, since that 2 is happening to everything, we want to get rid of that first. If it happens to everything, get rid of that first. So the first thing we're going to get rid of is that 2. And that 2 is multiplying. The next thing we're going to get rid of is that minus 7. And if we get rid of those two things, we'll have our answer. So to get rid of multiplication of 2, we do division of 2. So I'm going to draw a line through my equal sign. I'm going to divide by 2 on one side, divide by 2 on the other. This cancels out. I now have x minus 7 equals 10 divided by 2 is 5. So a number minus 7 equals 5. We have to get rid of minus 7. So multiply by 2 is gone. We're going to get rid of minus 7 by adding 7. We add 7 to one side. Add 7 to the other. This cancels out. We get x equals 5 plus 7. That's 12. That should be our solution to the problem. Let's check. 12 minus 7 is 5. 5 times 2 is 10. That's the right answer. So 12 does work in our problem to make a real solution. We're going to go ahead and move on to the next part, which is all about consecutive integers. I think they're awesome because we're going to use some algebra to solve some problems. Pay attention. It might be kind of complicated to figure out, but you guys can do it. Alright, so switching gears, we're going to talk about number theory. Number theory is how we have a relationship between two numbers and how they kind of work together. So we're going to find 3 consecutive, so that means 3 numbers in order that are odd. So they're odd and they add up to 57. So we're going to find 3 odd numbers that would add to 57. So first thing, if I asked you what three odd numbers were, you might say that 1 is an odd number, 3 is an odd number, and 5 is an odd number, correct? 1, 3, and 5. Those are all odd numbers. One of the first things we would do is we set n equal to the first number. So this first number we're going to say is n. So that's important to note, that the very first number is always the variable n. Now, we look at the second number. How would I go from the first odd number to the second odd number in reference to the letter n? Well, if this one is n, I have to add something to n to get to 3. To go from 1 to 3, I have to add 2. So our second odd number, since it's consecutive, would be n plus 2. Okay. And our third odd number still has to reference the very first odd number. How do I go from the first number to the last number in our pattern? Well, I take that first number, which is 1, in our case it's n, and we add what to 1 to get to 5? Well, we take n and we add 4. We take the first number and we add 4. So right now, I know that if I had 3 consecutive odd numbers, like 1, 3, and 5, it doesn't matter what consecutive odd numbers they are. You could go with bigger numbers. I like to use small numbers and write down what they represent. Once I know what they represent, we're going to actually solve it. So we're asking ourselves, how do we get from the second, or how do we get to the second number? All we got to do is say, do we add or subtract from our first n? So in this one, we said, okay, well, our first number, that's n. How do I get from this number to that number? I take that number and I add 2. How do I get to this number? Well, I look at my first number and I take that number and I add 4. So this represents 3 consecutive odd numbers. And I know that's kind of hard to understand, but these represent any odd numbers in the world as long as they're consecutive. I went with low numbers so I could come up with my equation. So if we had more numbers, we asked how to get there from the first number. That's how we got here. We're going to write a sentence and combine like terms to solve. So we know that if we take all of these numbers up, even though they weren't the right numbers, but they are consecutive, if we take these numbers that are in our equation now, our equation is this. If we know we have 3 consecutive odd numbers and they have a sum of 57, we're going to say that our sum is n plus 2 plus n plus 4. So this is my entire sentence. The first number is n, second number is n plus 2, and our third number is n plus 4. So these represent all 3 numbers adding together. They're going to equal 57. That's all we got to do is set it up that way. Now we're actually going to figure out what n equals. But before we do that, we're going to combine our like terms, things that look like each other that we can put together. 1n, 2n's, 3n's. So we have 3n's, we have 2 plus 4. That means we have a positive 6. So the problem we're really solving is we're solving 3 times n plus 6. And if we solve this, we'll figure out the first number. Once we have the first number, we can figure out all the other ones. So now we're going to solve this based on how we did previous problems. We're going to subtract 6, subtract 6. This cancels out. We have 3 times n equals 51. Now to solve that, we're going to divide by 3. Divide by 3. N is going to equal 51 divided by 3. Okay, so 51 divided by 3. 5 can divide by 3 one time. So I have 21 left. 21 divided by 3 is 7. So our first number for the letter n is equal to 17. Because 51 divided by 3 is 17. Now, if I want to know the next number, I'm going to take that first number, which is n, and I'm going to add 2 to it. So my second number of n plus 2 is going to equal 17 plus 2. That's 19. And my last number of n plus 4 means I take this first number and I add 4. So n plus 4 is going to equal 17 plus 4, that's 21. If I add these 3 numbers up, and they are consecutive, if I had 17, then I had 19, then I had 21, they should add up to make 57. So, go ahead and check it. 1 plus 9, that's 10. 10 plus 7, that's 17. Drop the 7, carry the 1. 1 plus 1 plus 1, that's 3. 3 plus 2, that's 5. So my three numbers that add together to make 57 is 17, 19, and 21. I want to do some more of these. I really like these. I think they're fun to do. Notice that I started with small numbers, and those small numbers got me to these really large numbers by using the rules that I wrote up here about consecutive integers. We're going to practice a few more of these, probably 2 or 3 more, and then we're probably going to call it good for the day. In our next example, we're going to be finding 3 consecutive even integers whose sum is 84. So we need 3 numbers that are even consecutively. So what 3 numbers could you say, any numbers in the world that are consecutive and even, just give me 3 of them. For me, I'm going to go small. Small is easy to work with. So starting, the first even number that I know is 2. The next even number that I know is 4. And the next even number I know is 6. Now I know that 2 plus 4 plus 6 does not equal 84. And that's okay. What we're going to do is we're going to use these as our bases. These are 3 numbers that are consecutive even numbers. 2, 4, 6. Next one would be 8 if we had 4. But we only have to look for 3. So we only wrote 3 numbers down. First thing we're going to do is we're going to set n equal to the first number. So 2 is now the letter n. Now I ask myself, how do I go from this number to that number? Well, I take the first number, which is n, and I add 2 to it. And then I look at the next one. How do I go from the first number to the last number? So I take my first number, which is n, and I'm going to add what to 2 to get to 6? Well, I'm going to add 4. So these 3 things right here represent the 3 numbers that would be adding together to equal 84. So all I'm going to do is write number 1 plus number 2 plus number 3 adds to make 84. n plus 2 plus n plus 4. So number 1 plus number 2 plus number 3 equals 84. We combine our like terms. 1n, 2n's, 3n's. So we have 3n's. We have 2 plus 4, that's 6, equals 84. Okay. Now all we got to do is solve this multi-step equation like we did earlier. We're going to get rid of adding 6 by subtracting 6. This cancels out. We have 3 times n equals 84 minus 6. That is 78. And now we're going to solve for this. We're going to divide by 3. Divide by 3. And I know that n equals 7 can divide by 3 twice. And I have 18 left. 18 divided by 3 is 6. So n equals 26. So now that we know that 78 divided by 3 is 26, we can say that our first number is 26. Our second number means we take our first number, which is n, and we're going to add 2. So our first number is 26. 26 plus 2, that's 28. Our last number, we're going to take the first number and add 4. 26 plus 4, that's 30. So these 3 numbers, if we add them together, should equal 84 if we're correct. Let's go ahead and check that. 26 plus 28 plus 30. This equals 84. So my 3 consecutive even numbers that add to make 84 are these 3 numbers. Alright, let's do one more problem. Trying this a little bit differently. Instead of doing even and odd, let's just do regular consecutive numbers that add to make a certain number. Alright. So in our final example, we're going to go for 4 numbers. We need 4 numbers that are consecutive, not even, not odd, just consecutive, that add to make 90. So let's just start small. What 4 numbers could we say are consecutive numbers? Well, I'm going to say 1, 2, 3, 4. Those are consecutive numbers. I'm going to say this first number is the variable n. The second number, all I have to do is take the first number and add 1 to get that number. The third number, I take the first number. To go from 1 to 3, I'm going to add 2. So I take n and I add 2 to it. And the final number, all the way over here, To go from 1 to 4, I'm going to add 3. So these all will add up to make 90. These on the bottom, not the top, but the bottom. What we're saying, the variables add up to equal. So now I'm going to write that sentence. 1n plus n plus 1 plus n plus 2 plus n plus 3 equals 90. First step, we're going to combine the things that look like each other. We have 1n, 2n's, 3n's, 4n's. So we have 4n's plus 1 plus 2 is 3. 3 plus 3, that's 6. So we have 4n's plus 6 equals 90. Now, we're going to work backwards to solve this problem. We're going to subtract 6. Subtract 6. We have 4 times something equals 84. Now we're going to divide by 4. Divide by 4. 8 can divide by 4 twice. 4 can divide by 4 once. So we have 21 is equal to our first number. The next number after 21, 22, 23, and 24. And if I add these numbers up, they should equal 90. So I'm going to check with the calculator. 21 plus 22 plus 23 plus 24. And in fact, I do get 90. So these are my 4 consecutive numbers, not even, not odd, but just consecutive like counting numbers, that if I add them together, I get 90. You guys did an awesome day. Make sure you like this video. Hopefully you guys like this stuff. I think this is pretty cool that you can set a variable equal to it using number theory, where we say that there's a relationship between things. So like this video, smash that notification bell, and subscribe if you haven't subscribed so you get notifications anytime these videos are uploaded. And I'll see you tomorrow.